I'm Ray Campbell, and I'm here to show you how to check for a correctly wired 110 outlet. Okay, the two devices that we use to check for these outlets are your circuit tester and your multimeter. The circuit tester you can purchase locally at a grocery store, hardware store, tool store, and they're relatively inexpensive. Your multimeters come with your toolkits, or you can purchase them locally at a hardware store or tool store. They're a little more expensive. Okay, so let's take a closer look at these two devices we can use for troubleshooting the outlets. This is a circuit tester. It's quick and easy. By checking the illumination of these lights against the chart here, we can tell very quickly if the outlet is wired correctly. However, with your multimeter, we can tell that exactly what the voltages are coming from the outlet, which is a more accurate reading, and at times it's not enough with this circuit tester. We actually need to know the voltages. Okay, so let's take a look at how we use these two devices. Here, with the use of the circuit tester, we can quickly tell that the outlet is wired correctly by the illumination of these two lights. But to get an accurate voltage reading, we have to use our multimeter. We have to check between our hot side, our neutral side, and our ground. First check would be across hot and neutral, and we want to read our line voltage of 120 volts. Then the next check will be between hot and ground. We want to read the same voltage. The last check we want to make is between neutral and ground, and we want to see 0.8 volts or less. The benefits of using the circuit tester is it's quick, but tells us only that it's wired correctly. The benefits of using a multimeter is it gives us an accurate output of the voltages on the outlet. Okay, now we're going to look at 5 different scenarios that you may encounter in the field of an incorrectly wired outlet. I've already inserted the circuit tester into the first outlet, indicating here that we have an open neutral by the one illuminated light. Over in the use of our multimeter, we're going to confirm those voltages. By inserting our meter leads across my hot and neutral, I'm getting about 45 volts. The reason we have poor voltages is because we have a feedback in the AC circuitry. As I check between my hot and ground, I'm getting my line voltage, which is what we are expecting to see. Between neutral and hot, or neutral and ground, I'm getting the same voltage we got earlier. So this confirms that we have an open neutral. Okay, in our next scenario, I've already inserted the circuit tester into the outlet, and it's indicating with these two illuminated outlet lights that we have a hot and ground reversed. We're going to confirm the voltages with our multimeter. Inserting our leads in between the hot and neutral side, and we're expecting to get 120 volts, and you can see we have 0. If I check between my neutral, my ground, and hot, I'm expecting to see line voltage, and that's what we get. Now I check between my neutral and ground, and I'm getting line voltage, which is not what we're expecting. We're expecting to see 0.8 volts or less. Alright, on our next scenario, I've inserted the circuit tester already, and you can see by the illumination of these two lights that we have a hot and neutral reversed. By using our multimeter, we're confirming these voltages. Inserting our test leads between our hot and neutral side, and you can see I'm expecting to see 120 volts, and that's what we're getting. When I check voltage between my hot and ground, I'm expecting to see line voltage, and I'm not. I got 0 volts. When I check between neutral and ground, I expect to see 0.8 volts or less, and I'm seeing 120 volts, thus indicating that I have a hot and neutral reversed. Okay, our next scenario, I've already inserted the circuit tester into the outlet, and you can see with the illumination of the single light that I have an open ground. Again, using our test leads, we can verify this by inserting between our hot and neutral, and my expected voltage reading there is line voltage, and that's what we're getting. Between my hot and ground, I'm getting very low voltage, which is an indication that I have an open ground. Between my neutral and ground, I've got basically the same voltage. Again, because of feedback in the AC circuitry, this is not what we're expecting, but a low voltage like that would indicate that we have an open ground. Okay, our last scenario, I've inserted the circuit tester into the outlet, and you can see I have no lights illuminating, indicating that I have an open hot. With the use of my test leads, I insert into my outlet, and you can see I have between a hot and neutral, 0 volts. Between hot and ground, 0 volts. Between neutral and ground, 0 volts. So, when you have no readings at all out of all 3 lugs, you have an open hot. Okay, in summary, we reviewed how a correctly wired outlet and incorrectly wired outlets were by the use of 2 tools, our circuit tester and our multimeter. Circuit tester gave us a quick review of how it was correctly wired or incorrectly wired, and the use of the multimeter indicated the exact voltages or incorrect voltages we saw at each outlet. Thank you for viewing this video. My name is Ray Campbell. Have a nice day.